Hello guys, so welcome back to another session. I think where we last left off, we were just setting the project. We downloaded some of the assets that he mentioned. I also used my own, and I just basically downloaded stuff from the internet. Since I'm not going to use this for commercial use, I think it'll be fine if I just use our assets just for learning purposes, I guess. And this is how it looks like. It kind of looks ridiculous, I know, like zombies in space, like it doesn't like what, but you know, it makes things a little bit more interesting for me, since you know it gives me a time to kind of learn how to I guess use my own assets rather than assets being given to me and just copying and pasting whatever the lecturer is doing. So yeah, so let's continue. I think before we continue, I think I gotta make it a little bit smaller because, yeah, they do kind of look pretty big. Um, if I remember correctly, they just changed the camera size. Let's see how much what will happen if I made it so that it's also the same camera size that he applied to. So size 10. Let's go do that. That's a little bit better. I'd say so. But now we gotta yeah, well, he hasn't done it, but oh no, he did. So we have to adjust it. Right, so I guess that's the best way to do it. So we just drop this. Or maybe. We want to keep the same aspect ratio. He is kind of hard to see, so maybe we can change his color. Maybe. Oh, pivot. So maybe we can make it at the bottom. Apply. Oh, I guess that's not how it works. Alright. Yeah. Oh, we can actually change the color. Yeah, I think making it wide as possible is the best thing we can do at this point. Yeah, that'd definitely be an issue since we have black background. It's kind of hard to see the character. But for now, I think I'm gonna leave it as it is. And if it does turn out to be like straining to the eye, then I'll probably just switch it up. Hold Alt. Oh, hold Alt. Oh, my bad. Also, maybe another fix or tuning would be to just change the camera size to like maybe something closer, like I don't know, like 7 or 8. Like that. I mean, that doesn't look too bad. I don't think. But I have a feeling like if you're basing it off 10, if he's basing it off 10, I think it'd be better for me to kind of work with what he had, since what he has, so that I don't screw things up. So I think this is fun. It just kind of looks funny every time I look at it. Before I continue, I guess I need to see if I can change the settings for VS Studio, because it'll be kind of like, in terms of readability, confusing, because here we have the convention of creating blocks by placing the starting bracket in a new line, but I'm more used to this format. So yeah, let's see if I can figure it out like quickly. If not, then I'll probably do it off screen or when I can. How to change the block placement. Maybe I'm thinking it should be preference, right? Preference, settings, font size, wrap, exclude, associations, text editor, support. Oh wait, that's a lot of settings. Yeah, I'm just gonna do it after, maybe later, or when I have time. So when we use this line of code here, Input.GetAxis, we're actually, I guess, referencing to this. And I guess with the pass string element, we would need to specify what property we're getting from here. Let's look at the documentation for it. Input.GetAxis. Alright, so it returns the value of the virtual axes is defined by the name. The value will be in range of -1 to 1 for keyboard and joystick input devices. The meaning of this value depends on the type of input control. For example, with the joystick's horizontal axes, a value of 1 means the stick is pushed all the way down, all the way to the right. And a value of -1 means that it's all the way to the left. A value of 0 means that the joystick is in neutral position. If the axis is mapped to the mouse, the value is different. It will not be in the range of -1 to 1. Instead, it will be the current mouse delta multiplied by the axis. So instead, it will be the current mouse delta multiplied by the axis sensitivity. Typically, a positive value means that the mouse is moving right or down. A negative value means the mouse is moving up, or left or up. This is frame rate independent. You do not need to be concerned about varying frame rates when using this value. Frame rate independent. To set up your input or view the options for axis time, go to Edit, Project Manager, Input Manager. This brings up the Input Manager, expand axes to see the list of your current inputs. Oh, it lists out all the current inputs that I have. You can now use one of these as the axis name to rename the input or change the positive button, etc. Expand one of the options and change the name in the name field or the positive button field. Also change the type to joystick axes to add new input. Add 1 to the number of the size field. So we can change the name, which is what it just mentioned. And then, so here are the controls. I guess left, right would be probably the left and right and arrow keys, and yeah, returns a value between -1 to 1, and left being -1, and the right returning 1. I guess we don't really need to know that. We just need to know that how to access these, right? Alt negative buttons, so we could alt negative buttons, or alt right? Alt buttons would be giving like alternative ways to read input. So we can go with the left or right arrow keys, or we can go with A or D, which is used for like mainly I guess FPS. Like, I guess for a game like this, having multiple options would be nice if people are used to playing FPS games. Gravity, dead, sensitivity, snap, invert. So the input type can be a key or a mouse button. We can also allow joystick, right? And if we wanted to add another input, we'd include one more. So right now, I guess like all of these can be inputs. Like we could read inputs from all of these. So if you want support from key or mouse button, or even joysticks, or like a controller, we'd probably add one, or this is just my idea. I'm not sure if it's correct or not, but maybe we will just increase the value by 1, so we can create our own custom control manager, I guess, or not control one of the control axes, and then or axi. I don't know, and then basically edit it so that it can also read controls from the joystick or controller. That's what I'm interpreting it as. So here we get the vertical and then the horizontal. So we reference the name. I see the name of the specific axes that we want. All right, so I guess we can continue since kind of know that now. So that was one that we used in the past, and if we look at here, it should be somewhere here. Get key down, submit. It's not here. Oh no, my bad. I completely forgot. So because get_axis is something else. Get key down is entirely different. This is if we want to get an axis, we have to look through here. My bad. So let's. Oh, they already have one. I didn't see that. Oh yeah, I didn't see that. So they have the controls for the joystick too. That's pretty cool. Oh, my back, my back, my back. So I think we're supposed to we're being challenged here. Let me just double check. So var here basically allows us to, I guess, not worry too much of what's being returned. In this case, it is a float, and we could declare it as a float. I still don't see the use of it quite yet, like especially for beginners, since I think they need to really see what's happening, what's being like stored, and the different types that we're using, because var just makes it kind of a little abstract, I guess. I don't know how to describe it, but like there's too many like implications. But I guess for now, like it does in a sense help in that you don't have to worry about it, but I figure like you do have to like I guess eventually know like what types you're doing. I don't know. It's just, I guess, my opinion. I'm still new to this, so I can't really say for sure. Yeah, I think we're getting a new challenge. Yeah, I think we're given a challenge to basically update the position of the player. So we could just call move method, and then we have to get the transform, which is transform dot position dot x equals new x position. I think that's how you do it. So basically we refer to the player's transform, or the position of the player, this component here, and then basically we update only the x value, of course, to that of the new delta. Oh. So I guess this is another reminder to myself, because I think I keep falling for it, but basically position is a variable, but I'm guessing maybe x or y are private. No, that's not it. I'm thinking that we can't apply values to these. Actually, I am quite curious. Why is that? Transform.position.x. I guess I can only say that you can't really set values to y or x, like let me see, position unity. Yeah, like we can only refer to them, but we can't really assign values to the individual x or y values. Alright, I think I'll try and remember that from now on. I think I keep making that mistake. I think that's good for now. Let me just try it out. So I'm moving. Whoa, that's way too fast. Like I'm barely even touching it. Like doing that. So I feel like, similar to the breakable blocks, we're gonna have to return, or we're gonna have to use the math. I forgot what it was, but it was it's like math clamp or something, which prevents the basically values returning that's greater than a certain amount. So if we have a set range between here and here, if we're moving the character, it'll only return like valid values for the X position if it's within the range that we set it on. Time.delta-time. Time.delta-time. Alright, let's see. So time.delta-time, the time in seconds it took to complete the last frame. Use this function to make your game frame rate independent. If you add or subtract a value every frame, chances are if you add or subtract to a value every frame, chances are you should multiply with time.delta-time. When you multiply with time.delta-time, you essentially express, I want to move this object 10 meters per second instead of 10 meters per frame. If you add or subtract a value every frame, chances are you should multiply with time.delta-time. When you multiply with time.delta-time, you essentially express, want to move this object 10 meters. So basically, what I'm seeing, or what I'm understanding, is that by multiplying a value with time.delta-time, we make it frame rate independent. So instead of calculating based on the frame, or like getting updated per frame, we're updating it by time, which it seems like it's a lot better, because there's probably more frames happening per second, I think, because like 60 frames per second would, like, I think, yeah, like there'd be 60 occurrences of move per frame per second, as opposed to 60, like for this case, it'd be like moving 10 meters times 60 per frame, right? That'd be way too fast, considering only one frame in 1 second. The amount of the meters would be like 600 meters within like a single second, and all you did was press one like key and it moves 600 meters essentially, if your game was running 60 frames per second. Hopefully I did the math right. But then if we based it off time.delta-time, it seems like we can, like I said, like I'm just repeating stuff just for my understanding. We multiply by delta-time, we make it frame rate independent, so we don't have to worry about it being updated frame by frame. Instead, we can make it time dependent and update only in respect to time. So we can make it 10 meters per second, which is a lot more stable than if we were updating 10 meters per frame. That's pretty cool. When called from inside mono behavior's fixed update, so I guess that's a different method, since we do have an update here, but then there's also another, seems like a method that the Unity engine reads, kind of like start and update. And so a fixed update returns the fixed frame rate delta time. Note that you should not rely on delta time from inside on GUI, since on GUI can be called multiple times per frame, and delta time would hold the same value each call until next frame, where it would be updated again. Not sure what that means yet, but I guess eventually we'll have to face that, since GUIs are like very important in game design. Alright, let's continue. Oh, that's also a good not argument. Good um, something to reflect on. Because if, let's say we're making a game, and if we do make it frame dependent, um, definitely the power of the computer would definitely give a different experience, and that's always not a good idea, especially when you're trying to create like a community, like where people can join together and uh, unite, I guess. But yeah, that's actually a good um, just an idea that popped up in my head. All right, let's see it in action. Oh, it definitely is slower. Dang, that does not feel natural at all. Wait, did it slide? Oh, it does kind of slide a little bit. So he's emphasizing the importance of making the behavior of our game the same throughout, no matter how powerful or how slow your computer is. It'll try to make it the same throughout all types of hardware, and I think that's very important. Or I think that's very interesting too. Like you never really think about it, and then when you do, it's kind of like something so obvious that it kind of shocks you when you realize it. Or I just never thought about it, I guess. So I forgot how he commented this. Was it, are these config params, I think? I think that's what he called it. So let's see the change. Yeah, that's a little bit better, but it doesn't feel natural still. There's like a little bit of like slipperiness, I guess would be a good way to describe it. I think we might need to add physics material maybe to kind of fix that. So we're given the challenge to basically be able to control the player in the y-axis as well. So we should probably do like this: for delta y equals Input.GetAxis vertical times that by Time.deltaTime to prevent it from being frame dependent, and multiply that by the move speed so that we can make it a little bit more natural and like not so stiff. And then we go new y position equals transform dot position dot y plus delta y, and then we update the player's position by setting a new vector at the location of new x position and new y position. So let it compile. I also want to try it out. I guess one thing to know as well, if we look at the project settings, like the keys for it would be, you know, the up or down arrow key and S or W. Just something to look at, I guess. So up, down. Oh, you can go diagonal too. That's pretty cool. Go in circles. Wait, I just want to check on something real quick. Let me look at the 3D aspect. I think they're in the same plane, right? Yeah, I think they're in the same plane. Should be good. Alright. Cool. Cool. Just a quick note, yeah, so far from this this course. I really like the way he challenges or gives challenges, because it really makes the student think, and I like it because it makes me think about it, and it helps me kind of interpret it in a way for me to understand, and in the future refer to whenever I get stuck on like a similar problem. I would just like think, oh yeah, we can do it this way, right? Or oh yeah, like how did we read input again, and then, or like, why is this, like, let's say if I forget to do this, so why is it moving too fast? Then I would think about like, oh yeah, like updating like a sprite's position per frame versus per second does make a huge impact. And I really like the way the course does that. I haven't tried any other course, of course. I can't really say for sure if they're not doing it, but having these challenges are a very good thing, especially for a beginner like me. One thing I do still have an issue with is like calculating the pixel per unit. That's still something I gotta get used to, but I have time now, so I can give it a shot to understand. Before we go, I just want to see if there's a site that can give out free particles. Free particles. Let me look at Reddit. Looking for dust particles. Free Unity particles. Because instead of having these, I was thinking of maybe if there's a way I could add like blood or something. This looks pretty cool. Probably download it. That's fine. And then we could probably switch it out for one of the particles there. And I'll just try it out. Maybe I could just change the colors on like one of these, because they look like a drop of blood kind of, and just change it to red. We'll see when the time comes. So he said that the reason why we use Viewport World Unit or World Point, sorry. Basically, before I read it, my guess is why we use it, based on his explanation, is because we want to make it a little bit more dynamic, in the sense that, you know, not everybody has the same resolution that they're playing at. So like they can have a screen that's like 1020 by 760, or someone else could have another screen resolution of 1920 by 1080. Or, you know, if I, you know, ever decide to put this on mobile, which, you know, we have the option to with Unity's build options, it's going to be a different resolution, entirely different resolution. So if we're using this method, we can make it so that it adjusts to whatever screen that we have, right? So like it kind of normalizes the value, because, you know, like he mentioned that we could always just make like a boundary value, like of a constant of this X position and this Y position. But then if we ever choose if the user has a bigger resolution screen, you know, it's gonna look weird, like if it can't go here because the boundary is like over here, because we made it static. So in order to make it dynamic, we normalize it so that whatever screen resolution that we have, it'll always be 00, 11, 01, and 10, right? And then basically by normalizing the values, we can adjust it to whatever screen we want, because then it'll always be the same coordinates, right? So that's actually pretty cool. So let me just read a little bit, maybe to understand a little bit better. Transforms position from viewport space into world space. Viewport space is normalized and relative to the camera. The bottom left of the viewport is 00, top right is 11. Z position is in world units from the camera. Note that the viewport to world point transforms an XY screen position into an XYZ position in 3D space. Oh, because you can also use this for 3D or 2D, is what I'm assuming. So we don't need to worry about that, I guess, for now. I guess it's just saying that we can also use it in a 3D space. Provide the function with a vector where the x, y, and components of the vector are screen coordinates, and the z component is the distance. Oh, it's z distance. We don't need to focus on that either. But let me just read it. Of resulting plane from the camera. So here we have a vector 3 camera view of the world. So it returns a position, an object, vector 3 position. Which you pass another vector 3 position. So you have 1, 1, and then the z component is the distance of the resulting plane from the camera. So the distance between the whatever we want from the camera in terms of the zeta axes. So we have a camera, get a component camera, get the viewport world. Alright, cool. Can I do it that too? Nope. I'm still unsure what this line of code does. I do know that it returns, or this object returns a vector 3, which is why we're able to access the x value. My guess right now is that it returns the basically the coordinates of like 0 as the min value, and then we could I guess when we're doing the max value, we're going to set it to 1 in the x, because the coordinates would be 0 0 and then 1 1. So if he does set it as for the x max as 1 1 0, then that'll kind of confirm it, but not too sure. Oh, I guess the max value of the x-axis. Alright, so we have another challenge. It's kind of a little bit of review because we did this in our previous project, the Block Breakers, but it's kind of been a while, so I gotta do it again. And let me just clamp F, I think it was what it's called. We go to Unity. Math.f.clamp. So, right, I remember exclusive and inclusive, right? So we clamp the values between the min and the max. Clamps between the given minimum float and the maximum float values. Returns the given float value. So it only returns a value if it's within a certain range. Returns the min value if the given value is less than min, and returns the max value if it returns if the value given is greater than the max value. Use clamp to restrict the value to range that is defined by the min and max values. So we have it here. Oh, we have an x min and x max. What do you know? So maybe this is kind of like the standard to label, like if we're labeling like a min or max of something, right? All right, so all right, let me. This will be the last thing because it looks like we're almost running out of time. So first, it sets up the setup boundaries, which instantiates these variables. So by the time update gets called, which, if I remember correctly from lifecycle, happens after start, we can get these values since they've been instantiated at this point. So to make sure that new x and new y position are within a certain range, we would need to clamp it here. Do we need any namespace that we have to include? It doesn't seem like it, so I think we're good. So we do need to call mathf. It's a static method. Mathf dot clamp the value here with x min and x max. We did not have y min or y max yet, so we don't need to do anything for this part, which I feel like he's gonna go over next time, but let me see if it works. Mathf does not contain clamp. It doesn't? Oh, yeah, right, I'm in C#, so the methods start with a capital. My bad. let's go. Nice. And we probably have to adjust it so that it doesn't, like we add like a half a value or something. But for now, I'm not gonna mess with it for now since I ran out of time for today. Let me see how much time we have left. Yeah, there seems to be a lot of time left. So let me just see what he does, and then we could end the video then. So he's gonna give another exercise, but I'm not gonna do it until tomorrow. Alright, so I'm gonna end the video here, and I'll see you guys tomorrow for another session. Peace.